just general information about what's artificial intelligence, machine learning. Nothing very. I'm just gonna go. Yeah, of course. Hello, it's been 5 minutes. I'm back again. Shocking. Welcome, guys. This is the second meeting of Santa Cruz Artificial Intelligence for this quarter. Thank you all for being here. Hope you guys are excited to get started with some less introductory stuff and more introductory stuff. I don't know. Going forward, we're going to be doing more technical things starting next week. So if you're really interested in doing the technical stuff, that's next week. So this is for people in the recording, but generally, yes. Today, we're going to be covering just generally what qualifies as artificial intelligence and machine learning, because it's not super well defined, solely because the field is super huge. So first, to really get you guys into the correct mindset for what we're going to be talking about here, if you could take around 30 seconds to a minute talking to the people who are around you, come up with just a general definition of what artificial intelligence and machine learning is, because it can be defined in a million different ways, but it's good to have something we can work off of. So talk amongst yourselves for about 30 seconds, then we'll come back.
Where it actually works to talk to each other.
Is it on?
Hit next and see.
No, it's on. Perfect.
Yep.
You're scrolling the page. It's a scroll wheel. It's basically a scroll wheel. Yes. You guys have Mac brain. You guys have Mac brain. I'm scrolling down the page, so I'm gonna go down the page by pressing the down button. Or you can use the down arrow to go down a slide.
Fair.
You guys are weird. I don't know what you're talking about. Yep. Okay. Let's bring it back. Does anyone have a definition for me? What do you think qualifies as artificial intelligence or machine learning? Just a couple hands would be helpful. Yeah. Yep. Technology or machinery that can mask as a being. Could you elaborate? What do you mean mask as a being? Nice. Yes, that definitely falls into a very explicit subset of artificial intelligence and machine learning, and we'll be touching on that in a little bit. Anyone else? Yes. So a program that is continuously improving, yes? Yes, it's another very good example of machine learning or artificial intelligence. Again, it's super broad. We're not going to get a single universal definition for this. Anyone else? Yes. A machine that can simulate thoughts. Yeah, I don't think we're quite there yet in terms of where we're at now, but maybe in the future. No, yeah, definitely. All this is possible either in the realm of what is happening now or in the realm of sci-fi, and is all considerably artificial intelligence. Anyone else before we move on into the meat of this discussion? Yeah. Yeah, so programs that correct and learn specific modes of data. So go for outcomes based off of some sort of data that they're learning. Yeah, again, also very correct. It's a pretty good definition of machine learning specifically. Alrighty, that more or less is just to get you guys in the correct mindset, because this is a huge thing. There is no singular definition for this. I'd really like to stress that. Artificial intelligence is a very broad and almost all-encompassing field that has tendrils in quite literally every aspect of life, whether it's attached to business, economics, biochemistry, it's everywhere. And we're going to give a few examples today of how that's the case. So in terms of applications for artificial intelligence, there's a lot. This is just generally a tree of different subsets. You can see here that there is machine learning, which is most commonly used as like a placeholder to be considered the same thing. It's not really, but we'll cover a couple nuances. Expert systems, which is a thing that's kind of out of date at this point. We'll cover why in a little bit. Natural language processing, which is to do with anything with spoken or written language. So if you're writing something down or you're doing some sort of translational task that's going to be doing natural language processing. This laser pointer does not want to work. Speech recognition, which is to the bottom right of expert systems, is separate from natural language. And again, it's interesting. I'd love to talk about it at length. But it's just recognizing spoken languages and either doing some sort of translation off of that or transcription. All of that is to do with actual speech recognition. And then planning is pretty fringe, not directly related to the rest of this. It's more, I think, approach to data. Robotics, I'd like to call an application of the other things, and vision is specifically teaching computers to see. So if you think of self-driving, that's a very common application. Okay, from there, we can really hop into the meat of these individual areas and give you guys a better idea of what each one entails.
So machine learning is basically when a computer system is able to learn and adapt based on data that you give it to train, and then, it'll figure out patterns, recognize things like that. And then on the test set, it's able to realize those patterns. Deep learning is machine learning that has multiple levels or layers. And that's where you can see more complex patterns by means of like neural networks. So natural language processing is one of the subsets that we talked about. It basically deals with just analyzing all kinds of human language, whether that's text or spoken. And it's actually a combination of linguistics, which involves like linear algebra, and computer science, like programming and things like that. Can anyone think of some examples of natural language processing? Turn to the people next to you, talk for a little bit, and then we'll share out.
Yes, that's going to be the main answer. I would not be surprised. Okay, sounds like it's dying down. Does anyone have any examples of natural language processing for me? Yeah. Grammarly? Yes. Grammarly, for those of you who don't use it, is basically just a way to manage your text. So like improve it for clarity, improve grammar, punctuation. I really love it. It's a very good example. It's a question of intrinsic understanding of what different parts of speech should be in relation to each other, and is a very good example of natural language processing. Anyone else? Yeah. Google Translate. Yes, it is. That is a very common task in natural language processing, specifically translating from one language to another, because there are similarities between languages, but it's not directly one-to-one, and you can't just do a literal one-to-one translation. So for those of you who are bilingual, for example, you can probably think in the different language, but it's not literally the same because most languages don't have the exact same structure as one another. So very important as a machine learning task. Anyone else? Yes. Yes, so long as there aren't the spoken component. And yes, as well also for speech recognition, there is a natural language processing element. But yes, that is a very good example. There's a lot of direct response to do that. And we'll cover more of this later on in the quarter and over the year. But yes, that is a common example as well. So the ones that we have here, machine translation, Google Translate. Sentiment analysis, which is something that we're going to be doing and is outlined here in this image, more or less just figuring out what the tone of a text is automatically, algorithmically. It's very common, useful in a lot of like customer-driven tasks. So if you think of like customer reviews for something, without having people necessarily assign a score to themselves, because people tend to be very biased, either assigning a 5-star or 1-star review, you'll be able to more accurately analyze the actual intent based off of their literal review, which it's a very useful tool. In addition to that, text summarization. So if you want to like get a summary of an article real quick, there's a lot of bots that are able to do that and condense it down to a paragraph or just the most essential bits of the article if you want the information. It's another very common task. And then text generation, like large language models. For those of you who used ChatGPT, that's a very classic and now contemporary example of natural language processing. Any questions so far? Perfect. Next up, we have speech recognition. This is very closely tied to natural language processing, but the approach is completely different. because you're not analyzing literal text, which can be just defined as a code more or less. You're analyzing audio waveforms, and that's way harder to analyze. It's a question of being able to take things in parallel. So at the same time, if you have a sentence written out like, I saw a cat, you're able to pass that into a program every word at once, versus speech, you're processing that in real time over time. So it's a different task and a different approach, and the solutions are often very different. Here in this image, this is an oversimplification of line. But what ends up happening a lot of the time is there's aspects of the speech that are boosted, so it's encoded into ways that are a bit more comprehensible to these machines. And then it does some sort of feature extraction, which varies from application to application, but is generally a little complicated, so it's out of the scope of what we're covering here. And then it does a lot of more specific machine learning based off of the task to generate a specific output that might be useful. And this is kind of the intersection of natural language processing, because you can map a lot of the time directly onto actual spoken and written languages and get an output that matches, that makes sense. Questions so far? Okay, perfect. So quickly, just take another like 15 seconds. You don't need to talk to each other if you don't want. Come up with like an example or two of where you might see speech recognition as an application. All right. Anyone have any examples for speech recognition for me? You've all used it, I'm sure, but yeah. Anyone have any specific examples that you can think of? Yeah. Yes, keyword recognition is very, very common. So if you guys have like called your bank, for example, and want to talk to customer support, they always put you through a robot first. And a lot of the time those suck because they're not really up to date. And yeah, that's a very common task of speech recognition, just being able to do automated response like over the phone. Anyone else? Yeah. Shazam, 100%, yes. That's a very common recognition task, not necessarily for speech, but for music. That's another very common implementation as well. Yeah. In the back there, yeah. Voice assistants, yes, like Siri or Alexa, 100%. All those are very common and often used things. So in terms of applications, we got virtual assistants. Thank you. AI chatbots, which are, I'd like to call it an extension of virtual assistants. And then voice-based authentication, like you would see over the phone, or you would see for like literally voice lock. If someone has a audio-based password, a lot of the time you use this type of thing, where it's not exactly the same, but it's similar. Or for example, if you have a custom wake word for a virtual assistant, a lot of time it's doing that similar voice authentication stuff. Cool. Any questions real quick? Excellent. Someone else press the buttons. I don't want that. Nice. All right. Computer vision. Computer vision is really, really cool. It's a massive, massive field. And it's literally giving the computer the ability to see. So if you can look at the top left there, that's basically just a diagram of what might be considered I don't know, a bounding box representation of what a computer might be seeing in a computer vision task. So if you have a self-driving car, you're going to want to be able to identify where people are walking, where there's other cars in traffic, and just other things that might be going on, like traffic lights and other types of important signage for speed limits and whatnot. And it's really a question of being able to discern this information from a visual medium, because our eyes work really well. We have really great pattern sensing brains, but computers don't. And so the whole question of this field is open-ended, because you're trying to get the computer to do something as well or better than people can. So it's, again, it's a very big and always improving field. Like you can see that there's no self-driving cars going everywhere yet, despite the year being 2023. So yeah, quickly think of an example if you want. Share out, it's 15 seconds as well. Yep. That's fine. Then we'll get into actual terminology in a little bit. Okie dokie. Does anyone have any examples for computer vision? Yeah. Sorry? What is that? You only look once. Oh, yeah. Do you mind explaining what that is for everyone else? Okay. Does anyone else know exactly what YOLO is? I remember hearing about it, but I don't remember. Do you know any? I think it was God, how many years ago was this? Was it like 3-4 years ago now? It was a large scale vision project, if I don't remember it. Regardless, yes, that is one application. I can't give exact specifics on it because my brain is in an encyclopedia. In the back. Oh, yeah, I don't remember what the algorithm is either, but yes, digital conversion of written text is an example of computer vision. It's a question of pattern recognition through text. Yeah. Yeah, Google Lens, 100%. Google Lens allows you to identify different plants or animals just by taking a photo of it and then doing a search. In the back. Yeah, self-driving. Very, very classic task. Anyone else? Yep. Snapchat filters. Yes, that's another good example of computer vision. Specifically, it's an application of facial recognition, either for you or for pets or whatever, because you need to be able to track like anchor points on people's faces. And so doing that automatically real time is a big task. Yeah. What is that? Oh, and it spits out the answer. Yeah, there you go. That's another good one. It also has combinations with some other machine learning tasks because you're going to be doing the combinations and asking it to actually translate it into solvable math. Yes, all very good solutions. Next. Perfect. So as you can see, Google Translate's here again. This is an intersection with natural language processing, as you'll probably come to see. Machine learning isn't really isolated disciplines. It's all intersectional and everything has a lot of overlap. So Google Translate is largely natural language processing, but if you have like a menu of something and you're taking a picture of it and it's in French and you can't read French, it'll be able to do real-time translation as a means through computer vision into text and then doing natural language processing to do the translation. Similarly for Google Lens, you're gonna have like, you can do the same thing with text and it does translation, but that's also with search function, which is it's not a necessarily typical application of machine learning or artificial intelligence, but it is one that is often done. So search engines are a type of artificial intelligence, but one that is a little out of the scope of what we're covering here because it's really, really big. It has crazy amounts of subsets. And then as well, self-driving cars, which is the stereotypical example, which we love. Next one. Perfect. Robotics. Robotics is a intersection of machine learning with hard circuitry, really. It's not really something I like to call a typical application, in that because you're doing a lot of things that are physical, right? You're going to be teaching the robot to identify specific things. So there's a lot of intersections with computer vision, for example. Like if you look at Boston Dynamics Spot, for example, the robot dog that they now sell, that has markers that you can train it on to do automatic routing around a construction site or a mine, and do video recording for like specific safety purposes. And a lot of that builds off of computer vision, and there's also additions of deep learning and speech recognition for like, if you want to give it verbal commands, for example. There isn't a lot to talk about here in terms of like specific applications because a lot of this stuff is just adaptation from computer vision or speech recognition or deep learning in general. Does anyone have any questions so far? Cool. All right, it's on. Excellent. And then lastly, expert systems. Expert systems have not really been in use since the turn of the century. So like 2000, more or less. And the reason is pretty complicated, but in essence, it's because an expert system is designed to emulate the expertise of a human. So more or less, if you can look at the diagram here, what would end up happening for the expert system as a whole is information from an expert, say a doctor, And they would be able to give a whole bunch of rules of like how you'd be able to diagnose a specific disease and put that into a knowledge base. And from there, what you end up doing in a large implementation of software, like hundreds of thousands of lines, is designing a lot of conditional statements in order to arrive at a pretty good conclusion. More or less just approximating the direct knowledge that an expert has into a series of answerable questions that you can run real time to a user. So you can see here, there's a user who doesn't really know exactly what they're doing. Say they want to diagnose a disease that they have. They feed in some of their symptoms into the user interface. The expert system does the backend calculation using all of the logic that it has and spits out a response, like with some amount of certainty whether or not a user has influenza, for example. Needless to say, these aren't very commonly used because a lot of systems like large language models, ChatGPT, can do it a lot faster and more accurately, solely just due to the more robust nature of the network. These are built with a lot of conditionals, so literally if and else statements in order to draw conclusions, and as a result, they're very slow and very bloated. So some that are pretty cool historically is ELIZA, which is an automated therapist from the 1960s. Mycin, which is bacterial identification from the 1970s, and Cadet, which I think is from the late 70s, early 80s for detecting cancer. And I say detecting with an asterisk because it doesn't actually detect cancer. It's asking for user input and then gives you an evaluation out. So it's pretty accurate, but it doesn't necessarily beat out a lot of more contemporary systems. And for those reasons, expert systems are not used as much anymore in favor of something that's a bit more contemporary. All right, keep going. Perfect. So that's more or less a quick glance at some of the subsets of artificial intelligence and machine learning that exist. But we also need to talk about the important vocabulary that there is. We're going to be referencing these a lot over the course of the quarter and over the course of the year. So if you want to take notes on this, feel free. It's not necessary, and we're going to keep referencing it and reminding you guys what these are over time. So for now, if you want to just be a sponge, be free to do so. And we're going to get into some important things we're going to be covering. So yeah. Okay. Generally speaking, there are three types of learning for any artificial intelligence or machine learning system. The first one, which is the thing that you're probably most familiar with, is supervised learning. More or less is you give the model a bunch of labeled data for it to learn. So in the example of, let's say, housing, you want to get a prediction out for a house that it hasn't seen. So you're going to be giving it a lot of information inward. So like, an example house is going to have the square footage, the amount of bathrooms, the amount of bedrooms, the size of the yard, whether or not it's gas or electric. And then it's going to have the price as a target variable. And all of that is considered labeled because it knows what the price is at the outset. So then you're going to be able to pass in something that you do not know, that it has not seen before, and get out a predicted price. This is supervised because you are giving it the answers for what it should be learning. It knows the price it's going to be targeting. It's not something that it's learning itself. Unsupervised learning, on the other hand, if you couldn't guess, is where you do not give it completed data. You do not give it the answer for what the thing should be, and it learns these groupings on its own, more or less. A lot of the time, this is used in less classification, but more regression, where you're trying to fit things. And we'll cover these in a little detail in a little further, but you're trying to just get it to spit things out that it learns as the shape of the data. So it's also pretty often used. I can't think of an example off the top of my head. But unsupervised learning is just basically you do not give it the target value, and it gives you out an answer for what it thinks it should be. And then reinforcement learning is continuous learning. So if you guys have seen anything on YouTube of like a robot learning to drive a car, a lot of the time this is reinforcement learning. Think of it as carrot and stick. There's rewards that you're trying to get it to optimize, and a stick as a punishment if it doesn't do it well. So you're going to be reducing the reward that it gets if it takes too long or if it crashes or whatever. And the reward that it gets is related directly to performance. And so a lot of these reinforcement learning algorithms are iterative improvement. So if you think of something like a genetic algorithm where you have a robot starting out doing something completely random, by the end it's going to learn the selected behavior and keep improving its performance, basically increasing the amount of reward that it gets. Okay, that's a lot of information. Any questions real quick before we move on? Awesome. Oh, in the back there, actually? Never mind. Okay, keep going. Awesome. Additional vocabulary that is pretty important. The concept of a hyperparameter. More or less, before you run a machine learning model, you have a bunch of stuff that you need to set in advance. So how long you want it to run, what the speed at which it should be learning is, the size of the network. All these are considered hyperparameters. These are things that the model cannot actually learn. So it is above a typical learned parameter. It's a hyperparameter for that reason. And all these are manually set, more or less. There's a few examples where there's networks that learn to set this. These are called hyper networks. We're really good at naming things, I promise. And those learn the hyperparameters that you want to set. And basically, the point of these are basically to constrain the set of all things that the model can learn by either limiting the amount of time that it can learn or limiting the amount of stuff it can learn over an amount of time. Classification, unrelated, is just getting a model to predict the class or type of an item. So whether or not it's a cat or a dog or a tree or a bush or something like that, or type of fish, doesn't really matter. Just getting it to predict what something is based off of additional criterion. Classification is typically always supervised learning. Want it to be able to predict what something is based off of a target that you're providing it. Otherwise, it's going to come up with groupings that might not necessarily make sense for your application. And then regression, think linear regression. You're trying to get a fit for what the data should be and plot things that aren't necessarily there, and looking for a relationship of some kind between these sets of data. Cool. Questions so far? Again, lots of information. Don't feel bad if you're not absorbing all of it. We're going to have lots of opportunities to learn all this pretty soon. Okay, cool. So that more or less covers the actual information that we're going to be covering today. Next things we wanted to do is just give you guys some things you could play with on your own, because there's a lot of these tools that are available that I actually don't think a lot of you might know about. And I'm excited to share some of them with you. If you guys like this sort of stuff to play with, then here's some things that you can mess around. Next one. Perfect. I don't know if you guys have heard of DALL-E 2, which is the last iteration of OpenAI's image generation, but DALL-E 3 is now available in Bing's chat. So you can provide it basically a prompt for what you want the image to generate, for the image for it to generate to be, and it spits something out that pretty much fits that. So as an example, I came up with like a cubism-inspired city at sunset. Make sure to use the vanishing point and don't include people in the image. And as you can see, it looks like cubism. It's a city. They all use the vanishing point to some extent, and it doesn't have people in it, and it's at sunset. So I think it did a decent job. And this is free to try. So unlike DALL-E 2, where you need to go into OpenAI's page and you have a certain amount of credits that you're probably able to use, go to Bing Chat and you can try this out. You just need to prompt it and it'll generate something for you. Really cool stuff. Very, very happy that it exists despite the weird sort of ethical stuff that I'd be happy to talk about at length another time. Next slide. Perfect. If you want something else, AI Dungeon, for those of you who like roguelikes or text-based adventure games, this used to be based off of GPT 2 and 3. This is before ChatGPT. Now it's based off of ChatGPT, which is just a more advanced version of the other two. And it automatically creates a text adventure for you based off of responses. You can pick different settings and whatnot, and it basically just generates a story that's never existed for you to play. Really, really fun. You can play for free. I think there is a paid option if you want something a bit more powerful, but it's pretty fun. It's cool to see that this is still improving. Last year I talked about it and it was a bit more limited, but now it's gotten a lot better. Yeah. And then the last one is it's called Music LM, which is a tool that Google is piloting from their AI test kitchen. More or less, you can generate music based off of a specific prompt. It's not incredible, but it generates music that sounds like music that kind of fits the prompt. This is a closed waitlist at this point. So if you guys want, once we put up these slides, you'll be able to join the waitlist for this and then mess around with it yourself. Or if you just want to listen to some things that are generated once you have the slides again, you can click on the number 1 that's kind of underneath the logo there, and that'll give you a link to the paper that they have with a bunch of example sounds. Yeah, generally pretty cool stuff. There's a whole bunch more. We just included a couple here that I think are pretty interesting, but there's so many more. And please send them to me. I always like finding more implementations of this stuff and messing around with it because I like annoying computers just a little bit. So yeah, I think that's more or less all of our actual instructive information for today. But before you go, if you go to the next slide, we have an important announcement for those of you who are interested in our competition this quarter. So Kevin is going to take it away from here.
Hi, everyone. As some of you have and others probably haven't heard of, this is the Sky is No Limit competition that's going to be running throughout the whole quarter. We will be giving you guys a theme, and then we will be giving workshops and stuff to help you guys create your own AI models and /or projects that have to do with the theme. And so without further ado, speaking of the theme, The theme for this quarter's is no limit competition is going to be hedge your bets. Now, feel free to do with that as you like. You can take any part of that and create your project off of it. We're very flexible on projects as long as it somehow ties to the theme. Yes. Nope. As long as you can tie it to the theme, we're happy. Yeah. The word hedges there, for example. Yeah. So, you know, as I said, we're very flexible. This is just to kind of get your wheels turning a little bit. If you go to the next slide, here's just some information about the competition itself. First, just what it is. You're going to be making an AI model or project. Second, you're going to be in teams of 1 to 4 people. So you're welcome to work on your own if you want. You're also welcome to find other people to work with, both today and as you see right up here, tomorrow's meeting, they're going to be Wednesdays we're going to have 2 meetings. I'll talk about how that works, but both today and tomorrow, just at the end of this, we'll have some time if you guys want to try and find teams for those of you who are interested, who want to talk about it, who want to, you know, all of that stuff. We'll have time to do that. So yeah, teams of 1 to 4 people. If you know people, you're welcome to join them. If you don't know people, we'll help you find people. Also, support. I know many of you who are here because you're new to AI and you want to learn more. And I just told you guys to make your own AI model from scratch. That's a little scary, right? We will be doing lots of workshops. As I said, again, I'm going to point over there, the 2 workshops every Wednesday. And we'll be helping you through every step of the process. So that said, if you know what you're doing, you're like, I know what I'm doing. I'm already finding the data right now. I'm already coding it up. Go ahead and do that. None of the workshops are mandatory. But if you're sitting there like, oh, this is scary, these workshops are very helpful. And if you miss one, that's why we also have the catch-up workshops before the main ones, so that you can be like, hey, I want to come to today's workshop, but today's workshop requires me to have done this previous stuff. Can you help me set it up so I can get to where I need to be? That's what those are for. So we have the weekly workshops there to help you. We also are always available on the Discord or however you can reach us to just give help, give suggestions. We're always there to help support you along this. That being said, this is still your AI project. This is something you guys can be happy in making like on your own and presenting as your own stuff. We're not going to be doing it for you. This is definitely going to be yours. And that's one of the most exciting things about this. In addition, some key dates, December 3rd, that's quite a ways away. It's near the end of the quarter. It's when submissions are going to be due, and we'll have a workshop on how to submit, what kind of stuff to focus on for the submissions. We'll cover that more in the future, but just know that this is your timetable. Submissions due December 3rd. That's kind of how much time you have to work on it. And then December 5th will be when, after all the submissions are in, we will have our judging event where we sit down. It is a competition. It says Sky's No Limit, not Sky's No Limit competition. Oh, well, that's my bad. It is a competition, so we will be having judging and we will have winners, possibly some kind of prizes. We're still figuring out some of the details, but some kind of prizes. And then also a party during the judging to celebrate everyone who participated and just look at all the cool, AI models and talk with the people who made them, which will be you guys. So, also, just kind of a quick overview. The main workshops that we're going to be doing are going to be, first, we're going to be looking at finding data. First we're going to be looking at coming up with a project, then finding data, then looking into like, how do I make a model? Sorry, thank you. And then it's just going to be a couple general meetings, and then Thanksgiving, there's no meeting because there's no Tuesday meeting, so there's no Wednesday meeting. Again, all of this stuff will be posted. You don't need to memorize anything. If you guys are curious, what's the timetable? And then week 9, that's the second to last week, we will be working on like submission help, helping you guys look at how do I present this data that I got? How do I present this model? And then finally, week 10 will be December 5th for the judging. So, any questions? Yes. The judging criteria we will get into, I think we will post it with the official announcement, but
more or less, what we did for last year's competitions, the judging criteria is more or less what people find is the most interesting model. This doesn't mean that it needs to be novel or anything that is literally going to change the world. This is a data science competition more than a machine learning one. The goal is for you guys to do things that we can't teach here, like how to find data and manage data and clean data, and then make something out of it. These aren't things that we can really directly teach you, and it's something that you need to do yourself. So the goal in terms of judging is who has a neat implementation of the thing, a novel interpretation of the theme, and just an interesting project as a whole. Don't feel really bad if you can't make something that is literally world-changing, because that's the point. But that's generally it.
And just to kind of reiterate that, it doesn't necessarily have to, be the best one out there to win. We're looking for really, really cool ideas. And if we can see that there's like a really cool idea that you're working on, and maybe it just needs a little more time before it starts producing like accurate results, we're still really interested in that. That's still really cool. It's still going to have a good chance in the judging. So yes, thank you. That was a very good question. Any other questions? Okay, well, should I wrap it up then?
All right. That will basically end the meeting for today. If you guys are interested in going to these workshops tomorrow, Kevin will be sending a communication probably later today, as far as I'm aware, with where that's going to be happening, exactly what the plan is. But yeah, that's basically everything for us today. Next week, we're going to be hopping into linear and logistic regression, and actually doing a little bit of coding. Nothing scary though. So thank you guys for coming, and feel free to come up if you have any questions. Sorry? No, this is just drop-in workshops. Get us coming back. There's the one running.
I'm assuming only like